Hello everyone, welcome back to my channel Study Motivators. Today I am going to solve one more problem related to the post tension beam. Okay, this is problem number 2. Before going to solve the problem, please do like, share and subscribe to my channel. Okay, this is problem number 2. A post tension T beam with unbonded tendon is made up of flange 300 mm wide. Means solution BF equal to 300 mm by 150 mm thick means TF equal to 150 mm. Okay, BF means width of the flange and TF means thickness of the flange. Okay, and width of the web is 150 mm means BW equal to 150 mm. The beam is pre-stressed by 25 wires of 5 mm dia with an effective stress of 65%. The wire is located at an effective depth of 320 mm means small d equal to 320 mm. Small d means effective depth. Okay, loss ratio is 0.8%. So loss ratio equal to 0.8 if FCK is 56 Newton per mm square. So FCK equal to 56 Newton per mm square. FP is 1650 Newton per mm square. So FP equal to 1650 Newton per mm square. Okay, find the flexure strength of the beam means M equal to question mark. Okay, so L by D ratio equal to 20 mm. L by D equal to 20 mm. Okay, this is the given data. Now draw the figure. So this is T beam. Okay, so BF equal to 300 mm means width of the flange BF equal to 300 mm, then TF equal to 150 mm means thickness of the flange equal to 150 mm. TF equal to 150 mm. Then BW equal to 150 mm means width of the web equal to 150 mm. BW equal to 150 mm. Next D equal to 320 mm means effective depth. So D equal to 320 mm. Okay, this is the web portion. This is the flange portion and this is the web portion. Okay, this is the figure. Now find the flexure strength of the beam. Okay, so formula M equal to FPU into AP into D minus 0.42 into XU. Okay, this is the formula. Here there are two unknowns here. First one is FPU value and second one is XU value. Okay, so step 1, let us calculate the effective reinforcement ratio. Okay, this is first step. So formula is AP into FPE divided by BD into FCK. Okay, now here we don't know AP value and FPE value. Okay, now AP formula equal to pi by 4 into D square. Okay, so pi by 4 into diameter is given in question 5 mm dia. So 5 square into also 24. Okay, So area value is 471.12 mm square. Okay, this is area value. Now we want FPE value. Okay, so FPE means the effective pre-existing steel after all losses. Okay, so formula is FPE equal to FP into loss ratio into percentage. Okay, FPE value is given in question 1650 into loss ratio is also given in question 0.8 into percentage means percentage is also given in question, so 65%. Okay, this 65% is converted into the decimal, so 65 divided by 100. Okay, now we got AP value as a 858 Newton per mm square. Okay, now we got AP value and FPE value. Okay, now find the AP into FPE divided by BD into FCK value. Okay, first AP. So AP is 471.12. Okay, so 471.12 into next FPE is 858 divided by B. B means width of the flange, so width of the flange is 300 into next D is effective depth 320 mm into FCK value is 56. Okay, now we got answer as a 0.075. Okay, then now from table 12 page 52 IS 1343 2012. Okay, so now we want FPU divided by FPE value and XU by D value. Okay, now we got AP into FPE divided by BD into FCK value is 0.075. Okay, and L by D ratio is 20 mm. Okay, so now we got AP into FPE divided by BD into FCK value is 0.075 and L by D ratio is 20 mm. So 0.075 corresponding values we don't know. Okay, now with the help of the interpolation we find 0.075 corresponding value. Okay, so 0.05 corresponding value is 1.32. Okay, now we want 0.075 corresponding value and 0.10 corresponding value is 1.26. Okay, so 0.05 corresponding value is 1.32. so 0.075 corresponding value we don't know, so 0.1 corresponding value is 1.26. Okay, now with the help of the interpolation we find 0.075 corresponding value. Okay, so now 1.32 plus bracket open this value minus this value. Okay, so 1.26 minus 1.32 divided by this value minus this value. Okay, so 0.10 minus 0.05 bracket close into bracket open, we want 0.075 corresponding value, so 0.075 minus 0.05. Okay, so 0.075 minus 0.05. Okay, now we got answer as a 1.29. Okay, so 0.075 corresponding value is 1.29. Okay, now FPU divided by FPE equal to 1.29. Okay, now we want FPU value. Okay, so FPU equal to cross multiplication FPE into 1.29. Okay, so FPE value is 858. So 858 into 1.29. So now we got answer as a 1106.82 Newton per mm square. Okay, this is the FPU value. Similarly, we want XU by D value. Okay, again with the help of the table. So we got AP into FP divided by BD into FCK value is 0.075 and L by D ratio is 20 mm. Okay, we don't know 0.075 corresponding value. With the help of the interpolation, we find 0.075 corresponding value. Okay, so 0.05 corresponding value is 0.10 and 0.10 corresponding value is 0.16. Okay, so 0.0 corresponding value is 0.16. We want 0.075 corresponding value. Okay, and 0.10 corresponding value is 0.32. Let's see. 0.05 corresponding value is 0.16 and 0.10 corresponding value is 0.32. Okay, now we want 0.075 corresponding value. Okay, again with the help of the interpolation, we find XU by D value and 0.075 corresponding value. Okay, now so 0.16 plus this value minus this value, 0.32 minus 0.16 divided by and 0.10 this value minus this, so 0.10 minus 0.05 bracket close into bracket open. Now we want 0.05 corresponding value, so this value minus this value. Okay, 0.075 minus 0.05. Okay, now we got answer as a 0.23. Okay, so 0.075 corresponding value is 0.23. So XU by D value is 0.23. Okay, now we want XU value. So XU equal to again cross multiplication D into 0.23. Okay, D value is given in question 320 into 0.23. Now we got answer as a 73.6 mm. So this value is less than TF value. Okay, first if T beam is given question, first find the XU is less than TF value or XU is greater than TF value. Okay, if XU is less than TF value, then it is considered as a neutral axis is within flange portion. Okay, if neutral axis is flange portion, then area is directly taken from question. Okay, if XU is greater than TF, then it is considered as a neutral axis within the web portion, then area is recalculated. Okay, so given T beam is within the flange. Okay, so neutral axis within flange portion because XU is less than TF value. Okay, then step number 2, calculate the flexure strength of beam. Okay, formula is M equal to FPU into AP into bracket open D minus 0.42 into XU. Okay, FP value is 1106.82. Okay, 1106.82 into AP value is 471.12. 471.12. Bracket open. D is given question. Effective depth 320 minus 0.42 into XC value is 73.6 mm. Okay, now we got answer as a 150.74 into 10⁶ Newton mm or 150.74 kilonewton meter. Okay, this is the final answer.